Introduction to Representation of Numbers on the Number Line. A water tank near the Calvary River, which originates in the Western Ghats, had steps inside it. A monkey jumped from a tree, but it did not notice the steps, that were a little far away. So, it tried jumping on the rocks along the sides of the tank, to reach the water level. The distance between the rocks was 1 foot, and the monkey carefully jumped from the first to the second rock, and from the second to the third rock. However, when the monkey reaches the third rock, it grows tired, and takes 6 equal jumps, to reach the fourth rock. A student studying the behavior of the monkeys, wanted to represent the jumps of the monkey in his project paper, by using a number line. Thus he has to find 6 points at equal intervals between 3 and 4. Come on, in this lesson, we shall see how to find the numbers, and their representation on a number line. Representation of numbers on the number line. We know that the numbers starting from 1, 2, 3, and so on till infinity, comprise the natural numbers denoted by the symbol n. To this collection of numbers, if we add 0, then this collection of infinite numbers is called whole numbers, which are denoted by the symbol w. To this set of numbers, if we add negative numbers like -1, -2 and so on, we get the set of integers denoted by the symbol z. What are the numbers that are still left on the number line? There are numbers like half, 1/4, and so on. If we add such numbers to the existing set of integers, we get a new set of numbers. This new set is called the set of rational numbers denoted by the letter q. Rational comes from the word ratio, and q comes from the word quotient. A number r is called a rational number, if it can be written in the form p by q, where p and q are integers, and q is not equal to 0. For example, -25 can be written as -25 divided by 1, here, p equals -25, and q equals 1. Hope this makes it clear about the definition of rational numbers. Can you now say the sets that are included under rational numbers? Clearly, rational numbers include natural numbers, whole numbers and integers. Now consider the rational numbers displayed on the screen. 1 by 2, 2 by 4, 10 by 20, 25 by 50, and 47 by 94. On simplifying these numbers, we get that each of the rational numbers equals 1 by 2. Hence, these are equivalent rational numbers or fractions. However, when we represent p by q on the number line, we assume that q is not equal to 0, and that p and q have no common factors other than 1. So, on the number line, among the infinitely many fractions equivalent to 1 by 2, we will choose 1 by 2 to represent all of them. Hope you are clear now. Now, let us try solving a few problems. Problems on representation of numbers on the number line. Now let's try solving the problem that we considered in the introduction. Solution: we are given that the monkey takes 6 jumps between rocks 3 and 4. On the number line, these are nothing but the 6 rational numbers between 3 and 4. We could thus help the scientist, if we find these 6 rational numbers. Representing the positions of the rocks using a number line, we get the number line shown on the screen, where the interval between each rock is assumed to be 1 foot. When we place 6 points between the integers 3 and 4, we get 7 intervals between the 2 points. Thus to get 6 rational numbers between 3 and 4, the denominator must be 6 plus 1, that is 7. The next step is to multiply, and divide the number at the end points, by the integer 7. Thus, we get the values 21 by 7 and 28 by 7, as the values at the end points, as shown on the screen. Now we could easily get the 6 rational numbers, by changing the numerator from 22 till 27, as displayed. Thus by representing the jumps of the monkey using the number line, we found the 6 rational numbers between the integers 3 and 4. Observe that, the interval between 3 and 4, can also be divided into 8 equal intervals, or more. By representing on a number line, can you guess the maximum number of rational numbers that can be found between any two integers? Since there are infinite points between any 2 points on a number line, we could say that there are infinitely many rationals between any two rational numbers. Friends, hope this makes it clear about the representation of numbers on the number line. Conclusion. Do you think that the rational numbers make up the entire number line? No, that's not right. The fact is that there are infinitely many more numbers left on the number line. The amazing thing is that there are infinitely many numbers lying between any two numbers too. Summary. Let's now summarize what we have learnt in this lesson. A number R is called a rational number if it can be written in the form P by Q, where P and Q are integers, and Q is not equal to 0. While representing the rational number P by Q on the number line, we assume that Q is not equal to 0, and that P and Q have no common factors other than 1. And there are infinitely many rational numbers between any two rational numbers.